Hi everyone, it's Sorkin. Today we have a problem when we need to design a calendar without double booking. And we are giving this example. In this case, we can add the first one. We can book the first event because it starts at 10 and it ends at 20. So we are returning true for this case. And for the next one, it starts at 15. We cannot book this event because our first event that we already added to our calendar, it ends at 20, so that's why we are returning false in this case. And for the last one, we can add that to our calendar because the first event ends at 20 and the next one starts at 20, so we can add that and we are returning true in this case. Let's say we have this calendar from 0 to 40 and we are adding events to our calendar. So first let's add from 10 to 20. Can we add that? Yes. This interval is empty, so we are adding 10 to 20. And as we are adding, we are also creating a hash map where the key is our start, 10, and the end is our value. So we are adding that to our hash map. So the next one is, let's add 20 to 30. Can we add that? Yes, we can add. This interval also empty, so it's available. We are adding that, and we are adding that to our hash map or hash table. So 20, 30, we are adding here. What's the next one? The next one, let's say that we want to add more, 15 and 25. Can we add that here? Can we add 15 and 25, right? So no, we cannot add because it's a double booking. In this case, we cannot add it. But how we are going to perform that check? How we are going to do that? Let's define our step. So our first step in this case, our steps. So let's define our first step. What would be our first step? Our first step is, let's just call this one start, right? Start, 25, 15 is the start, and the 25 is end. So the first rule that we need to do is we need to find the key from our hash map that is the largest key that is less than our start time. So in our case, the largest, which is less than our start time, is 10. So let's just call it previous, right? Previous. In our case, it equals to 10, right? And for the next, we need to find the key that is the smallest key that comes after our start. So in our case, start is 15, and the next is equals to what? Next is equals to 20, right? So next is equals to 20. So in order to add this one to our calendar, that's our rule, right? So in order to add that, in this case, right, our 15, so our 15 should be more than the end time for 10, right? So it means that in this case, our start should be more than or equal to from our map, right? From our map, our previous value. So in this case, it's 20, right? So it should be more than, our start should be more than or equal to the end time for this one, right? For our previous. So in this case, it's 15, so it's less than that. So start is less than our end time here, so we cannot add that. But the another one, let's say that let's say that we have added the first one 10, 15, so we can add the start. What is the next what is the next constraint that we have here? The next one is that our end time, right? Our end should be less than our next. So our end should be less than or equal to our next. So this is the condition. If this is met, so in our case, both of them they do not meet these constraints. But if they meet, then we are adding that to our hash map. That's our first part. The other part is that how we are going to effectively how we are going to effectively add and remove that to which data structure we should use in this case, right? So let's say for each event, for each event that we are adding, we need to find two keys, right? We need to find the previous key and we need to find the next key. So which data structure we are going to use to effectively add our events to our calendar? So in our case, we are going to use a red black tree. Red black tree is a specific tree, which is a self-balancing binary search tree, and in this case the time complexity would be log of n, right? Log of n, and then n is the number of the events that are already in the calendar. So we are going to implement that in Java, and in Java the implementation of the red black tree is tree map, and the time complexity in our case is log of n. So we are going to use red black tree in order to store our events in our calendar, and the implementation of the red black tree in Java is a tree map. So we are using a tree map, keys being the start of our event and the values being the end of our event. So it has two functions, two methods, floor key and the ceiling key. So this one will return us the smallest, this one will return us the key that is large, the largest key that is smaller than our start, and the ceiling key will return us the smallest key that is larger than our start. So, and the first thing that we are checking here, we are getting for the floor key for the largest that is smaller than our start. So we are getting the end, and we are checking that it should be, as we have seen in previous example, it should be less than or equal to our start. And that's the first condition, or it should be equal to null. If it's equals to null, then in that case we can just add, because there is no key. And for the next condition is that our ceiling key, it should be null, or it should be more than or equal to our end. If these conditions are met, then in that case we are adding our start and end to our calendar and returning true. If not, then we are returning false. So time complexity, as we have seen earlier, it's a log of n, and for the space complexity is determined by our tree map, and it's n, the number of the events that are in calendar. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.